Hi, and a big welcome back to all my subscribers. And if you're not a subscriber, why not? Today is the next in my series of keywords in programming languages. Now, I'm currently doing the C programming language, and today we're going to explore the for loops. And stick with me to the end because we go through the basic syntax and all of that, but we also cover some advanced topics and advanced concepts and various tips and tricks and things that you want to know. So even if you're a long time C programmer, you may find this of interest. I'm sorry that it's mostly done in PowerPoint. It's a bit of a death by PowerPoint, but I didn't know how else to present the information. Please, in the comments, give me some suggestions. Okay, so let's just get stuck into it. Let's just do a deep dive into the for statement in C. Now, the basic syntax is very straightforward. So what we've got here is initialization, condition, and then update. So the initialization is you just initialize the variables. The condition is when does the loop stop, and then the update is what does it do on each iteration. So it's really straightforward and easy to do. You will typically see things like for int a equals 0, a is less than 10, a plus plus. So just increment a by 1. So that's really straightforward, and that's your typical for loop. Now, the primary purpose is to facilitate repeated execution of a block of code. It's good at traversing arrays, performing instructions a fixed number of times. It's a very concise and expressive way to do things other than other looping constructs like while and do while. It's very readable. It makes the code easy to read and understand. And loop controls, it reduces the likelihood of errors. And while they're powerful, it's essential to understand that to use them, when to use them, as opposed to using something like a while loop. Now, the use cases for a for loop are where the execution depends on a specific condition or a number of times. So count controlled loops is the thing. 95% of all for loops are basically counting loops, where it's iterating through a block of arrays or number or a repetitive task. One of the most common is traversing elements of an array. And it's good at generating a sequence of numbers as well, because it's controlling the initialization and the conditions. Now, there are cautions and pitfalls. You need to ensure that loop termination is done properly. The scope of the variables inside of a for loop are within the for loop, so it's a local variable scope. So don't forget that it's local scope. People get off by one errors because the loop bounds are not correctly picked. So this is where, I don't know, they start at 1 instead of 0, or they start at 0 instead of 1. For example, if you're going through an array, arrays start at 0, but you've initialized your counter at 1, then you'll be have an off by 1 error. So you should look at best practices and make sure that you can understand, the various challenges within a for loop. But it's relatively straightforward. Now, there are some tips and tricks you can do here. So because the for loop allows the declaration and use of multiple loop control variables, you can do this to perform sort of parallel iterations. So it helps because it handles the parallel operations in a single loop. It reduces the amount of computational complexity and the amount of computations that the computer has to do, and it simplifies the management of the loop conditions. And also you can have like while, you can have a infinite loop. You can also do an infinite loop in for just by not putting anything in between in the condition and the update. Now, loop unrolling is one of the advanced concepts that you get in C. In C++, there are other things. You can use Pragma to do I don't know, parallelization and virtualization and things, but you can't do that in normal C. But you can do loop unrolling. So this is basically reducing the overhead of the loop control. And the idea here is that you can, rather than increment singly over the loop, you can increment more than one. And it results in better performance, especially in scenarios where loop overhead is a factor. Now, obviously, you should profile this and make sure that it does actually work. Pipeline processors are really good for this. And in fact, most compilers will do loop unrolling for you. Like, you might not need to do it. So that's why I'm saying check and do some profiling, because your compiler might be already doing it. So you don't need to. But basically, an example of loop unrolling is this. So rather than incrementing I once, you increment I by 2, and then you just do I and I plus 1 within this loop. So it basically saves the calculation, and it's doing half the number of loops, basically. So it's relatively easy and straightforward. It's easy to understand, so no problem. I mean, that's it basically for the for loop. It's a relatively easy and straightforward thing to do. There are some things that can be counterintuitive, but there are advanced concepts that you should look into using when you can, like loop unrolling and things like that. So that's it from me today. I hope you like this series. If you do, please like and subscribe and all of that, and press the button, and I will see you later.